The following is a presentation of the Control Trends Podcasting Network.
Aaron Gorka on Young Gun for Control Trends, reporting here on Next Generation Innovation, AG from ANT on NGI. I'm here still at Conestoga College. It's fun, right? And I'm here with John and Jim, and I'm going to let them introduce themselves. And we're in the engineering area here, and we're going to talk about a few different things. So, John, why don't we start with you? Introduce yourself and, something a little bit about you.
Good afternoon, Aaron. Thanks for inviting me. My name is John Longcar, and I'm an instructor here at Conestoga College in the Building Systems Engineering program. And I work in conjunction with a fellow professor on the project design course. I've got close to, over 20 years since I've graduated. Various levels of working in consulting and in the private sector and utilities as well.
What's your favorite part of it all? Which one's your favorite spot that you've ever worked?
Dealing with my customers, dealing with the people, and knowing that when I walk away, I've helped them. That's the biggest, makes me want to go do it again tomorrow.
Probably why you're here teaching, to help kids be even better at what they do.
Absolutely. I'm a big fan of giving back. People have taken time out of their schedule to help me, such as Jim. He's helped me for over 10 years, and it's my turn to give it back, and I welcome it gladly.
And Jim, your turn now. Why don't you introduce yourself, a little bit about you?
Hi, I'm Jim Bayshard. I'm the program coordinator for the Architecture Project and Facility Management program at Conestoga College. We're trying to educate people with a real strength in project management, but understanding facility management. So understanding a building, but also understanding the economics behind a building.
So people who are hearing this podcast are typically either a contractor, could be a distributor as well of control systems, who are typically the barrier or sometimes the connector between a contractor and an end user, what we would call. So we were talking a lot about the fine details between a project and facility management. What are you guys what are you teaching in particular that would help students pull it together? Because it's something that we all struggle with, and a lot of distributors are behaving as the intermediate between them.
Well, we're trying to get them to understand the term the little black box, because it's not going over well with facility managers. The attempt here is to get students to understand that there's mechanical systems and then there's control systems, and you have to understand both. Also what you actually need in the building to actually get things to work properly. And I think that when you kind of put all the onus on the controls, you're not really getting the full picture of what's going on.
So would you find, in your experience and time here, Jim is of veteran status, what we call from a young gun or rookie to the vet, or you use the word grandpa, so we're here at story time here. Everybody's got to learn, and this is what we're here for. In your experience, how have you kind of found the best mix between the mechanical side and the control side, either bringing them together or single sourcing, or how has that worked for you when you do have to do a recommissioning or you do have real problems, or PM?
Yeah, dealing with that is, I think you have to have a good understanding of what the mechanical, I'll just say mechanical systems, HVAC, how they actually operate, what they were designed to do. But you also have to understand what the control system is supposed to do. And I think when you don't separate those out, but bring both parties together, you're not going to get a full understanding of how things actually go. So you have a desire for the building to be comfortable. You can't just blame the software, because sometimes they just aren't coordinating sufficiently to actually do the job you think they're supposed to do.
John, one thing, he hit comfort there, and what I want to go on now is like that battle between comfort and energy efficiency, right? Optimizing energy consumption, maximizing occupant comfort. Why is that so hard?
Just routine. This is the common notion in industry is, depending on whom you're speaking with, is this is how we've done it in the past. This is how it works. I know how to provide or clear the call. I can put the fire out. Mm-hmm. But that's not necessarily the right answer. That's actually putting the Band-Aid. You're not actually solving the problem. Yeah. The problem is you can still meet thermal comfort, but yet save on our natural resources. Mm-hmm. And that's by management. We were speaking about nighttime setbacks.
Yeah.
Occupied versus unoccupied mode. my biggest question is, why would you heat a room that's empty?
Yeah.
And that notion is now coming more and more. Or having a throttle position, say variable frequency drives on your air handling units, as opposed to the on-off position or the 0, 50, and 100. I only need 34% for the next 6 hours because I'm unoccupied. I just want to move the air.
So if it's really what you need is good facility managers that can be dynamic and changing these schedules, because in a campus, like we're on here, like some rooms are occupied, some are not. Do you preheat or pre-cool, say, a room, or pre-pump some fresh air in so when the students walk in, or do you wait for that set point to hit, warm and everybody be groggy and then cool it down for them? Like, is there strategies, do you think, on a facility management side where you could get comfort only when you need it?
Well, if you're going by time clock schedules, you're always going to have an issue with that. If you switch to occupancy, sensing occupancy, which is a coming trend, well, I guess a requirement in the Ontario Building Code now, at least parts of it, is that you solve all those problems, because if nobody's there, it's on nights. And if somebody shows up, it's only going to take a few minutes for the space to be comfortable if it's a decently designed system. So I think it depends on which way you're focusing on it. But I know when you go by occupancy, all these issues of time clocks and all this other stuff and daylight savings time just simply disappear, because you're just judging the building is actually in use. Therefore, you get what you need.
Or the room with VAVs and reheats and stuff like that.
You're guessing.
Yeah.
Where the proper approach could be using CO2 sensors.
Yep. Yeah.
But then with those devices, you have to maintain them. As we were speaking earlier, when you do your PMs, you have to do them. You have to make sure, as you would with your car, change the oil, change the tranny fluid, do your checks to make sure that you're actually getting what you paid for, that you're getting the value per dollar spent, and you don't want to let things break and then ignore it.
So I want to jump back to Jim on this one, because you actually put together a really good metric that we just talked about of like how you determine that your service provider is doing a good job on PM. Because like as an end user, then I can jump back to you, John, and just kind of put on there we go, that work or don't work to make sure that you're getting the people to do it live. So we'll start with you on your metrics.
Well, usually you talk about this stuff as a dollar sign, and as to how much money should you spend on preventive maintenance versus breakdown maintenance and issues like that. I've always looked at it as I want enough preventive maintenance that I only have the occasional emergency call, but I can fix it really quick. So therefore I can be the hero. But if you're not getting any emergency calls, you're spending too much on PM, and that has to be avoided. But if you're getting too many emergency calls, why not translate that money into PM? So the metric is you do get the occasional call, but it's fixed quickly because people know what's going on. And I think that's where the economics of it fit right in, because you know you're in a good spot.
Yeah.
But the trend of over preventive maintenance, you're just paying for things you don't really need.
Yeah.
And how do you tell if you're overdoing it?
Yeah. So then, we go in and we start doing proper preventive maintenance, right? How do you make sure, say, in your experience in working in the energy side, that the people, all the parties involved, because this is into retro commissioning, essentially doing proper PM should be retro commissioning, right? Tailoring it to different outdoor air temperatures and scenarios when you're there, ideally. How do you make sure that this works? Or what have you seen good contractors or good people do?
It's I don't say retro commission. I say continuous commissioning, because that's what you need to do. Say, for example, in boilers, if you do a boiler tune-up, say every 6 months, it's low cost, but it tells you whether you're using too much air or not enough air. Or even so, there's telltales that the plant engineer, you look at the color of the flame. What's the color of the flame? Is the flame dancing? So there's little telltales you can see. The color of the products of combustion, how dirty it is, what's your temperatures. So there's little signs for certain things that are kind of easy. You say, okay, this is kind of a work experience. And then there's other measures where you just have to look at your trending schedules. So measurement and verification is key. You can't get better if you don't measure. There is that designs where you're measuring way too much and you have too much data, and it's just nonsensical now.
Yeah.
But you need to measure so that you can know where you're coming from and where you're going to.
Are you doing like energy analytics at times, correct? I mean, I don't know if we want to throw products out there. Typically in our industry, it's like a SkySpark would be our standard one that everybody listening would use all through. This is a big Niagara community that'll be hearing this, but analytics is a hot topic. What have you seen work for it, and what do you actually use that's valuable in your analytics?
I revert back to old school analytics. I need the raw data,
Yep.
and then through conversation with the operators, so I can understand the data.
What's going on in that building?
Right.
Like we can see it from afar.
Well, I need to know what's the audience, what's the purpose of the building, what else is inside the building, because the building is organic. It's always moving, living, breathing, aging. Yeah. So it's those conversations that put some framework around the data, so that you can understand it a little better, and just instead of saying, this data set's garbage. Well, not necessarily. Yeah. It does have value because, this happened. Now I understand.
Yeah, somebody was going on there. Go ahead, Jim.
Yeah, I recently participated in a webinar on with the British Institute of Facility Management, and they actually did some case studies of control issues. And it was quite interesting where today we manage so much data and nobody knows what the heck it means. and they had a much simpler approach. Measure the end result, what you want, and the controls either work or they don't work.
Yeah.
So is the temperature at the right spot at the time? And when you do that, then you just go back to the controls people and say, here's your data trend of what's actually happening in the room. Fix it.
Yes, and you need that trend, you need that understanding to be able to do that, yes.
Mm-hmm. So you're measuring more the end result than trying to measure this data point and that data point and another data point and a damper position and all this stuff. Measure the end results that you want, and then the system should be performing to that. And when you actually have a data log of, say, temperature every minute or 5 minutes or whatever you're using, you can tell exactly is the system working or not without measuring all these other points.
So, who do you guys think, either or, is responsible for? I mean, I guess in any instance it's different, but who is responsible to do that research? Is it a team effort? Is it the controls guy? Is it facility management? Is it energy audits? Like who is it, or is it a team?
I think the question is who is accountable and who is responsible.
Oh, there we go. Okay, yeah, sure.
I see. The owner of the facility, who pays the bill, they are accountable.
Okay, yeah.
Whose responsibilities? I see a lot of green teams right now becoming bigger and more apparent, and participation is increasing.
Because it is different than a typical PM, but they should fit together, right? Mm-hmm. And really, they are as we get more tools. I don't think there's probably only a few people, in North America, maybe even the world, that have really perfected this art so far. But how could we get towards that perfection? I mean, it may or may not be attainable. How do we get there, right?
It's an art.
Yeah.
It's an art because every place is different. Every climate is different.
Yeah, it's true. You go farther south and you're dealing with totally just different equipment, right?
Exactly. The inclination to the sun.
Yes.
On how your building's facing, how much glass do you have?
Yeah, outdoor air temperature sensors. It absolutely boggles my mind that a $20, $40 sensor, one of them, or I expect one of them, is controlling this whole facility. If that's in the sun, it's not going to read the right temperature right now, and none of that building is going to run. If that sensor's faulty, I mean, you can kind of see it, but that's still going to cause energy and comfort and big problems. $20 sensor.
Yeah, but when it comes to the systems, HVAC and control and all that type of thing, that who's ever responsible for the operations has to understand what the systems are supposed to do.
That's the hammer down point
and,
here.
And it otherwise you're blaming the controls person, you're blaming the person who's complaining, you're blaming everybody else, but you're not understanding what the system's actually designed to do. And I'm going to break it down into two sections: what the mechanical systems actually do, what the control systems actually do, whether they match or not, and then what's the end result you actually want. You have to put all three together to actually do energy management. what's one of the bigger culprits of energy management right now, at least what I'm hearing, is leaking outdoor air dampers.
Yep.
The building's unoccupied, outdoor dampers are leaking by 5% for 18 hours or all weekend.
Yep.
And it's just simple basic maintenance. And that's extremely easy to, temperature points will tell you exactly what's going on.
But if you're not looking at the controls, you're not checking the unit theoretically properly either, then you and the data that should be being pulled and available in modern society, you're never going to get that. So I really appreciate that feedback of, the facility operators, the people in the building really should, and that is their responsibility to understand what they're managing.
Yeah.
And you're hammering that to your students.
Well, I wouldn't put it that way, but we're trying.
Yeah, we're doing the best we can on it. So let's switch gears to the kids. Let's switch gears to students. Why don't you guys talk about, you don't have to think about like particular kids or not, whatnot, but what are you seeing coming through your program? I know this is first year for you on this one, but other programs and whatnot. Who's coming up through Conestoga, and what are they going to do out in the world? Hopefully,
They're going to make us better. I can say that. But the students from my generation to today, and I went back to school a couple of years ago.
Yeah.
The students, they're smart. They're engaged. They're smart, and they have a sense of social responsibility now. Whereas when I was coming up, I graduated over 20 years ago. It was different back then.
It was more job related, and again, like task related, different drive. Yeah.
Right. Where now
society was different. Their need, like your need at that time, and your gut was a little different than what my gut and the kids younger than me, that Gen Z. So I want to talk about that too. That's the kids younger than me are scarier than I am, I think. But
yeah, the students, they're just ahead. They're socially responsible now, and they want to contribute. And they want to contribute now.
That's probably the thing, and that's great feedback for everybody that's scared of the millennials or Gen Z coming up. They do care, maybe more than anybody's cared so far. So,
and they're not afraid to voice.
Yeah, because it's easy to, right? Through keyboards, basically, we've grown up voicing our opinions. What do you think, Jim?
Well, what I see in our program, because we have basically smaller classes, you get to know them fairly well after a while, because they're not 200 or 300 sitting in a room. There's only 20 or 30 depending on what's going on.
And that's rewarding too.
Absolutely.
Professors.
But if I just talk about it from facilities management isn't thought of as a interesting career by the young people.
Which is wrong. Let's just say this on it, that trades and everything this college is representing it's super valuable and very high paying out there right now, and
well, I just looked at the IFMA website.
What's IFMA?
International Facility Management Association. Our program is actually accredited by the IFMA Foundation, so we're pretty good standing there.
Absolutely.
That they were saying that the concern. A huge percentage of FMs are retiring shortly.
Yes.
The average pay, according to IFMA, is over $94,000 a year U.S.
So let's hold on that there, kids. It's just a young gun kind of thing. What the average is? But
it's a senior FM. It's not the junior position. But until there's a little bit more perception that FM's a good, well-paying career. It's stable. It's long-term. It isn't running all over, chasing construction projects all over the country.
Yeah.
Better home life. Until that starts to come across, it's hard to sell.
So what would you sell the, like, what you just hit on a bunch what is the sell of it? Yeah.
I don't know. I wish I did. But what our program does is students come out, and once their career starts, they slowly seem to switch over to more of an FM focus as they mature in the industry. Yeah. But you look at a PM, project manager, and maybe 3 years experience, you can get a good job.
Yep.
If you're an FM, they want 8-10 years experience before you're going to get a good job.
So you got to experience everything before you get
Yeah,
there anyway.
you've got
Gotta
to
break it.
because you have
Yeah.
to understand a fair amount to be able to do it.
FM, I mean, you have everything. So what we're focusing on controls, but what other things would be in FM? I mean, everything basically.
It's everything that isn't core business.
Building science,
Yeah.
and there's no expiration for
No.
for this profession. It's not. There's
It's
not
evolving probably faster right now than anything, right? The Internet of Things, and there's IBCon and different conferences out there. ASHRAE is a major one, but it's kind of overwhelming. But yeah, technology and building technologies it's wild.
But the other part of is FM is thought of as the tail end after it's built, where today FM starts when there's a business problem.
Yeah.
So what's the solution? And the fact that your design, if you mess up the design, and an FM is going to live with it.
Yep.
So you have to really go back to the fact that FM starts with the business problem to the proper solution, and then implementing it properly, and then seeing that it works. So there's a longer lifespan to it.
What's the most important step, do you think? Besides, say, outside of initial design, like attention to detail, initial design, vital. But what is there a most important part, or?
No, it's actually at the design stage
It is,
to
yeah.
get better input
No
at
matter
the
what,
design
yeah.
stage, and then once you're into the routine operation, it's just a reasonable level of preventive maintenance. It's not rocket science at that point.
No.
And there's no great big magic technique that's going to all of a sudden save you energy when you've messed up the design.
So okay, let's go on that. Like a messed up design. How do you deal with that? Because
it's what typically happens when talking money. It's capital versus O&M. Is the project a turnkey? Then it's all about capital.
Yeah.
Cheapest cost for the largest revenue. But unfortunately, the people that are going to live in that space aren't involved into the design.
Mm-hmm.
And so they're left with what they get, and they have to make it work.
Or tenants like building fit ups and stuff like that. But even like that just makes a bigger mess of it.
It's
a lot of times.
when the purpose of the building has substantially changed, then there is the propensity for issues to happen. If a building was originally designed as a foundry and is now just a parts sorting, you really should look at the air, because the air system was designed as a foundry. If you don't change it, you're going to be pushing hundreds of thousands of CFM of air through it when you only need a fraction of it, because the air quality is far better now.
Yeah. And then the need for it to be so good is it's not being contaminated nearly as much. Interesting. Yeah. Cool. So, I mean, I kind of hit through a lot of the questions. We're at about the 22-minute mark here. So, usually it's about the time where we can take a little breather on it now. What I'm going to kind of go is, what advice would you guys, give to your younger selves? Say you put yourselves in, I had noted here, at leaving high school in your 20s and your 30s, but let's just focus on the kids. Like, put yourself in, your students, picture your student's age. Give advice back to yourself on that. And you can think about this one. This is a big one, so we can think about it. Yeah.
The biggest key when you're graduating, and I tell my son and my daughter who are young, they don't quite understand it, but if you can get past it in your head that you can accept that you don't know, so you know that you don't know, you will be farther ahead in industry. And that's to say that you're not the expert coming out of school. So
it's not what you know that's going to get you in trouble. It's what you don't know that will cause big problems.
Right. So when you
flooding.
speak to people, listen.
Yeah.
Listen first, then speak.
And that is tough. That is tough. So listen first and speak. And again, it's not what you know that's going to get you in trouble. It's what you don't know.
Yes.
And accept the fact you don't know everything.
Absolutely.
Resonate in there.
Yeah, very similar. I'll describe it as basic problem solving. You don't know everything. Don't be scared to ask people that have specialized knowledge in it. I mean, that's what they're there for. Mm-hmm. But if you follow a good pattern of understanding what the problem is, spending the time analyzing the question, so you make sure you're solving the right problem. basically look at the options for solving that problem, which is sometimes done too shallow, where you're not looking at enough different options because you're actually understanding the question better when you look at a variety of options. And once you ID the option, then it's a matter of proper project management or budgeting or whatever is necessary to do it. When you follow a pattern like that, even when it's answering a quiz or doing a project within your course, when you actually follow that pattern, what happens is when you get challenged by the professor, you actually have a better understanding, and you'll be able to debate or discuss some of those issues because you've actually thought about it, versus that's what I did. Sorry for the slam.
Yeah, that's what it's all about. Yeah, absolutely.
When you just say that's what I did, then you haven't really understood the question. And in industry, in industry, it's understanding the problem.
That's something I just finished a book called The Effective Executive by Peter Drucker. It took me 5 years to read it, interestingly enough, but not that effective, I guess. Ironically. But one of the things he says about decision making is, like, to your point, is you're an executive with a big team, ask your whole team, right? First thing he says, if it's unanimous, create conflict, because somebody's not got deep enough on it, right? So you do, it's if everybody agrees, nobody's gone deep enough. So that would be the advice.
It's very true.
Take your time, dive deep, understand the problem first, because when we develop our software, that's my role between the customer, our contractors, and our developers. I'm the blocker between everybody. And a customer may say, come to me with it could be anything, a problem with this. They want I don't know, some kind of problem with the software, or idea for it. And their idea to how to implement it may not work with how the system's built. So how can we achieve either the same thing or something different creatively? But if you don't understand the need that they have, like what is it that they actually need? They need to organize their preventive maintenance schedule better. It's like they don't need a different button, or maybe they do just need a different button. What do we got to do? You got to dive deep into what that problem is, or you're going to mask it and have a bigger problem. I guess from here, final words. If you guys have like a, one story you want to share that every kid will, for the kids out there, like maybe a major problem, something funny that happened, in your careers or something.
Maybe.
Something like that. Yeah. Just so, we can leave with, sending people away laughing and going like, oh yeah, I've been there kind of thing. You don't have to put any names out there.
No, I was thinking of a phone call. This is many years ago that one of the operating staff phoned me in the middle of the winter and said there's something wrong with a certain mechanical system and wanted to know what I knew about it. And I replied, it's broke. and I remember he thought about it for a second and he says, yeah, how are you supposed to know? You're 25 miles away.
There you go.
So it was the best answer I could give him because there's no way I could answer that off the top of my head.
All I know is that's broken, man.
It's broke.
Let's work on it together. Anything popping in your head on it?
I do one story that kind of pops up, and it's just on perspective. I was with an senior engineer from another company. We went and visited a long-term care facility, and we're talking about energy conservation, how we can be efficient. And the senior engineer said, well, there's nothing here for me. I'm looking at the energy per square feet. He's talking all these metrics. But because I was somewhat new to the field, and I learned earlier to ask lots of questions.
Yep.
Well, I just looked at the senior engineer and I said, well, I'm sorry that you're using the wrong metrics. And so it was gapped about 20 years of experience.
And you're telling him that.
I'm telling him, I'm like, well, they really don't look at energy per square foot because it was the healthcare industry. They look at it energy per head, per occupant, which was a transformational aha in this senior engineer's head. He was like, wow, okay, now I get why I'm here.
Something here.
Now I know why I'm here. I'm like, yeah, it's all in the language and the audience that you're speaking with. So that's the funny thing. more so because I actually learned, because I asked the questions, because I
Never
got
be scared to challenge, right?
no, because I got hammered once, as we all do, by not asking the question, and yeah, sometimes you learn, sometimes you have to repeat.
It's a 3-strike thing. Sometimes you get 4, right? Try not to, but you never know.
Well, yeah, that's the funny thing is it's not every story is different, and it's okay to ask what the story is.
Yeah. And if you don't, you're not diving deep enough probably, and you're not going to get the right answer.
Correct.
I think that's pretty good for the kids or for anybody. So thank you guys for your time. I really appreciate it. About half an hour mark. It was pretty fun, right?
Yeah.
Cool. Okay.
It was okay.
Cool. Well, there you go. AG from A&T on NGI.
Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what